All right. So we are going to be giving solution to question number 3, as you can see it on your screen. Please, you can pause it and read it very well. Then we'll go straight to the solution here on the board. Right. Without wasting much of our time, we are to use the Poisson distribution where lambda is equals to 3, and also from the question, the average core per minute is also given as k, or from the formula using that k will be given. Or when k is equals to this, what will you do? Now, the Poisson distribution formula, we have something like x equals k, then it equals to exponential raised to power minus 3 multiplying your lambda raised to power k divided by your k factorial. Okay, now please, like I always say, right, formula in statistics as a course, mathematics as a course is very, very important. Once you are able to state the formula and being able to pick out those perimeters in the formula, trust me, you've gotten around 70% of that question. Now, the A part says when k is equal to 4. So what do? We substitute this value into this. Also note that this symbol you see in mathematics is a constant number, just the way you have pi to be 3.142. That is how this also is a constant number of 2 point something. So we'll just bring it out here and solve it directly. Now let's substitute into this formula. Probability of x equals 4 now, because k is 4, will now be equal to exponential raised to power minus 3. Then your lambda now is 3, so 3 raised to power 4 all over 4 factorial. Please note that 4 factorial is the same as 4 times 3 times 2 times 1, which is 24. So we'll replace 24 with this. And also know that 3 raised to power 4 is the same as 3 times 3 times 3 times 3, which is 81. So we'll replace this with this. Then take us note also that exponent, this alone is 2.7182. Then exponential raised to power minus 3 is the same thing as 1 over exponential raised to power 3, which is equal to 1 over 2. Let's approximate to like 3 decimal place. 1 over 2.718 raised to the power of 3, which is the same thing as 1 over, if you raise this to power 3, you're going to have, so when you divide 1 by this, you're going to have, which is now the value for this, because what I'm doing is whatever we arrive when we divide, we'll now substitute it here, and then we'll solve. We already have factorial to be this, we already have this to be this. Now we're looking for this. So finally, exponent raised to power minus 3 will now be equal to 0.049787. So now we already have the value. You can approximate to maybe 4 decimal places and so on and so forth. What we'll do now, we've gotten all the value. Let's impute. So we have p x equals to 4 will now be equal to, we've gotten the value for this, which is 0.049787 times 81 divided by 24. Okay, 4 factorial is 24, 3 raised to power 4 is 81, and this ultrasound raised to power 3 is 0.049787. So when we simplify this up and then divide it, we have 4.032747 divided by 24. That is, if you use what you have there to multiply it in 1, you have this, then divide by 24. So probability of x equals to 4, 0.1680. So this is the solution you get when your k is exactly 4. Is that okay? Now let's go to part B of this. The B says at least 2 cores Now what this at least means is that the least call you have is 2, but above 2 is perfect. So probability of x greater than or equals to 2 is what you are going to be doing, which is the same thing as 1 minus probability of x less than 2. And probability of x less than 2 can be given as 1 minus probability of x equals to 0 plus probability of x equals to 1. So we're going to be looking for probability when k is 0 and when k is 1. We add it together, we subtract it from 1. That will be our answer to at least 2 calls. Remember the formula also. So probability of x greater than or equal to 2 will now be equal to exponent. So we have to just repeat. Then lambda raised to power k all over k factorial. If you know from the a part, we already have value for this, right? But k will be 0. So we're going to have exponential raised to power 3 give us value as 0.049787, right? So that is for this. Then times, remember our lambda is 3, but k is 0 raised to power 0 because we are solving for probability of x equals 0 and k is 0. Then 0 factorial raised to power 0 is 1, and 0 factorial also is 1. So when you do this, you will now realize that this probability of x equals 0. You now realize that probability of x equals 0 is equal to 0.049787. Now let's check probability of x equals 1. So we have this is given already, which is this. So 0.049787 times 3 raised to power 1 all over 1 factorial. Please, 1 factorial is 1. 3 raised to power 1 is still 3. So we are going to have 0.049787 times 3. If you multiply everything here by 3, whatever you arrive at will now be your answer when that is the probability of x equals 1, which is 0.149361. Now we've gotten, this is what we are looking for. We've gotten for k equals 0 and k equals 1. So we add it together and subtract it from 1, which means probability of x greater than 2 or equal to 2 will now be 1 minus, for our 0 we had 0.049787 plus, for 1 we have 0.149361. So we're going to bring them together. So what that means is that 1 minus, if you add all these together, you have 0.199148. If you subtract this from this, so at least 2 cos, when you subtract this from this, you are going to have 0.800852. So this is what you are going to get. So for the C part, it says less than 2 cos. So this is the formula like I told you. And for probability of x less than 2 cos is the same thing as probability of x equals to 0 cos plus probability of x equals to 1 cos. So these are for less than 2 cos. Okay, now we've already gotten the value for probability of x equals to 0 cos from the B. You can just pick it up from there, there is no crime. And also we've gotten the value for probability of x equals to 1 cos from the B part. So we'll still just bring it back here. Remember, the only thing we're not going to do is to subtract it from 1, because we're talking about less than 2 cos. Probability of x equals 0 cos will now be 0.049787. Then probability of x equals 1 from the values we got in the B part plus 0.149361. So when you sum all this together, that will be your final answer. 0.19148. So for less than 2 cos, you are going to have this. Okay. for exactly focus, which is part A, we've done that. So please take note of what we've done, ask questions where necessary, and always remember your formula: Poisson formula, normal distribution, z-test, whatever. Always remember all these formulas and don't mix them up. Okay, don't go and mix least square with any other formula and the rest. Just take note of this. Then bye bye.